Hello. Morning, guys. Good morning, everybody. We're going to wait a few minutes just to let some people come in, and then we'll start, okay? Yeah, a little bit better. Yeah. Okay.
Hello?
Hi.
Hello?
Hello.
Hi.
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 How are you guys doing this morning? Good?
Yep.
Awesome.
We're doing good.
Hi.
Bad.
You're doing bad? Oh, no, that's not good. Don't worry. You guys will like this presentation today. I have some cool stuff for you guys. A cool experiment. It's really fun, too, so I think you're going to like it. So let's just people maybe like 2 more minutes to log in, and then I'll start, okay?
Hi. Hi, Ava.
Oh, hey. Hi, guys.
Do you see the bump on my forehead?
Hey.
Hello.
Good morning. Hello.
I'm Alexa the Great.
Hey.
Okay, now you sit down.
We're going to wait 1 more minute, and then we're going to start, all right?
Okay. Okay.
You see, I'm trying to play. I have an umbrella out on my porch, and I'm trying to decide how much I want to put it up. I think this will be good. Okay. All right. So we're going to go ahead and get started, guys. First off, hello to everybody. For those of you guys that were able to join me last time, welcome back. If you're new to this, I'm so excited to have you. Maybe you watched the recording. But basically how it's going to go is I got some questions. I'm going to answer 3 questions today with a little presentation, and then we're going to do an experiment that is very fun and cool. I think you guys are going to enjoy it. All right. So without further ado, I'm going to go ahead and get started. So you might see me, I'm not really sure, but I'm going to start sharing my screen. That's what you're really going to see. So we can start talking about our topic for today. All right. So hang tight, and here we go. Okay. So now I think you guys are able to see my screen, which is perfect. And let's see here. Okay. Yeah, okay, cool. So for today's meeting, we are going to be talking about space stuff. And you're familiar with space and outer space, and astronauts, all that kind of stuff. But maybe you aren't, and that's all right. But today we're going to kind of go through what that's all about. And the questions we're trying to answer that I got were, why is Pluto not a planet? I'm sure you've heard of Pluto before, but pretty recently it was classified as not being a planet. So we're going to try to understand why it's not a planet today. The next thing we're going to take a look at is, why can't we live in outer space? What's preventing us from living in outer space? I'm sure you've heard of SpaceX and all these other companies that are trying to get people in outer space, but there are a lot of logistical problems with that. So we're going to be talking about that. And then the last thing is, what would we do if we found extraterrestrials? Okay. And maybe you believe in extraterrestrials, maybe you don't. We're going to dive in and kind of see the science behind it. All right. So let's go ahead and start. So the first thing we're going to talk about is, what is outer space? Okay, I'm sure you've heard the word before, but it's kind of a big term, and we don't usually have it really clearly defined. So I'm going to start by talking about this idea called the Big Bang Theory. This is it was a popular TV show too, but it's based on the scientific idea that about 13.7 billion years ago, which is a really long time, okay? Think about that, 13.7 billion years ago, there was a huge explosion in the universe, okay? And a bunch of dust and gas was basically thrown everywhere, okay? And we're gonna learn what happened to that dust and gas, because there's lots of things now in space, so it's not just dust and gas anymore. But the Big Bang Theory is this big explosion of dust and gas, okay? So you can kind of picture that in your head and keep that in the back of your mind as we keep going through this to make some more sense. Hey, really quick, is someone drawing on the presentation? Because it looks like I'm getting, and the pictures are being covered up. There we go, thank you. Okay, so defining what space is, space starts about 60 miles outside of our atmosphere. So if you remember from the greenhouse gases presentation, when I was talking about the atmosphere is like a giant bubble around Earth. So that contains us, animals, plants, trees, our air, our sunlight, the sunlight that we get at least, that is called our atmosphere. It's like a little bubble. So space starts about 60 miles outside of that bubble. And space is essentially a vacuum, okay? And when I say a vacuum, you can think of your vacuum cleaner, which is kind of similar, but basically it has no air. There is no air in space. So this, now if you're thinking, well, that could be a problem, it is a problem. And we're gonna get into later why it's a problem for us living in space. But basically space is a vacuum, there is no air. So another thing too, that we get a lot of questions is like, well, we see pictures of space, and like the one I have my mouse on right now, we see pictures of space and it's pitch black, right? But our skies are blue. You know, what's going on? Is it just because there's no sun? But there is sun in space. So the real reason is that air particles are like little funnels, and they take in light and they scatter it. So here on Earth, right, we have air. That's what we're breathing right now. We have tons of air particles that are able to take in sunlight and scatter it, and that's what gives our the sky such a blue color, and it kind of brightens it. And of course, then at night, when the globe has turned and we're not facing the sun anymore, the air particles don't have any light to scatter. So that's why it's dark at night. But in space, right, there is no air. So if you don't have any air, there is no light for those there's no light that can be absorbed and scattered. So without any air, you don't see light in space, which is why it's so pitch black dark, okay? So you might still be wondering, well, wait a second, Ava, you know, there's a lot of stars in space, you know, don't those brighten up the sky? The universe is around 15 billion years old. So stars have been able to kind of move in their own orbit, and sometimes they move closer to us, but it takes them a long time to get there. Okay, stars are just kind of orbiting around, and sometimes they're farther away, sometimes they're closer. And you can see with this picture here, you know, some of the stars are clearly brighter than others, and that could most likely be because they're closer to us. So space is getting brighter to our eyes as those stars are coming closer, but still it's going to take a long time for space to be really bright because we're waiting for those stars to come closer to us to kind of light it up like a flashlight. So even though there is no air in space, right, there is stuff in space. There's no air, but there is dust. There are tiny trace amounts of gases like hydrogen and helium. And there's small floating particles that a lot of times have chipped off of planets. You could think asteroids, that sort of thing. And also space debris. And space debris is basically human-made objects that are left floating around in space, okay? Usually it's old spacecraft and, you know, waste from missions that were sent into space, but there is a lot of space debris. And this is a really good picture depicting kind of what space debris looks like. It's pieces of space that are kind of floating around, that sort of thing. And then the other thing here is a picture of two astronauts. You guys see them. And in space, there is no gravity. And gravity is the force of attraction between two objects, okay? So when you think of gravity, you probably heard, well, Earth has gravity. It does. Earth has gravity, and it's like a magnet. Earth and us, we're kind of smooshing together. That's what holds us down to Earth. So gravity is this force of attraction between two objects. Let's bring them together. And there is no gravity in space, which is why people float in space, right? They're not being attached down to anything. Then the last thing I want to hit on is how big is space? We measure space's size in light years, okay? And a light year is basically how far light can travel in 1 year. So it's actually pretty intuitive, but it's kind of a weird definition. So light in 1 year can travel about 6 trillion miles, okay? One beam of light can travel about 6 trillion miles, and that's how we measure the size of space. So the size of space is about 13.7 billion light years large. So think 13.7 billion light years times every light year is 6 trillion miles. So space is huge, okay? It's very, very, very big. And we measure it through light years, okay? I hope that kind of makes sense to you guys, what just kind of general definition of outer space. Okay, so now I want to go into stars, okay? And stars are going back to that Big Bang Theory when I'm talking about all this dust and gas in space. This is kind of where stars start to come into play. So stars are made from clouds of dust, okay? You have all this dust floating around in the Big Bang Theory, and basically rumblings inside the cloud, they build up these little dust balls, okay? So the cloud starts to rumble, and we start to build this little dust ball. And the ball actually starts to have weight. It starts to have mass. It's like a little ball that you're actually like holding in your hand. I kind of think of it like a Christmas ornament. Like it actually has a little bit of weight. So the dust condenses into this little ball. Then what happens is that dust ball eventually starts to collapse. Okay? So it starts to collapse. And I'm going to show you guys a demonstration later of what that would kind of look like. But the dust ball starts to collapse. And inside of that dust ball, it starts to get really hot. Because if you guys know anything about friction, right? When all that dust is moving and it's like collapsing, the dust particles are moving against each other. And that's creating heat, okay? So the inside of the dust ball is actually getting kind of hot. And we call this stage of the star, we call it the protostar, okay? Because there isn't really any light yet. It's just kind of like this little hot little ball of dust, okay? So we don't really know what's going on yet. So now this protostar, this dust ball is gonna keep on collapsing, okay? And sometimes this little ball can break up into pieces. And not all of that collapse is going to become part of the final star. Some of it will float off into space, and that's why we have so much dust in space. But because this collapse is producing so much heat, when the star gets hot enough, it has a little bit of hydrogen inside, and that's going to react with the heat, okay? So at the inside of the star, we have a little bit, remember how I said there's a little bit of hydrogen in space, and that hydrogen a lot of times is inside of the stars, in the core of stars. So when you have this collapse and it's heating up, that hydrogen is going to react with the heat and boom, you're going to get light and energy, okay? So basically the main players in the star equation are you have this dust ball, heat's now being produced, and it's going to react with the inside hydrogen, okay? And so now we have this energy, right? And the energy is kind of what gives stars their brightness. And a star basically is just a collapsing little dust ball. Okay, and it just is eating off of that, whatever hydrogen it has inside, it's eating it, and it just keeps on collapsing, it keeps on producing light. So it's not just like a continuous thing, it is going to be, it is continuous. I'm sorry, I was thinking something else, but it's a continuous thing where it just keeps on collapsing and keeps on producing energy and light, okay? So an example of a star is the sun. The sun is huge star, okay? And the sun can collapse for many years. It's estimated to be collapsing for 50 million years, okay? So think about that. A dust ball collapsing for 50 million years continuously, and that's how we're producing light, okay? It's just like a cycle. And the inside of the star is able to put this pressure on it to get the dust ball to force it to keep collapsing. So there's like pressure, and we're pushing all that dust down, and that's why we're getting the light. Okay, and it heats and energy all kind of playing into that equation. And then another thing too that's kind of interesting is that large stars actually burn out more quickly than small stars. And the reason is they get hotter faster and they use up their hydrogen inside of their star little shell. They use it up more quickly. So if you use that more quickly, if they burn through that hydrogen, there's not going to be a ton left. So they're going to burn out more quickly and have shorter lives. Even though they will be brighter for a little bit, they're going to die out faster. Okay, so here's a picture, and you guys can see the variety of stars we have. We have one star that's super bright, and this is probably going to be, I'd say, a big star that's collapsing really quickly, but it's going to die out soon. And then you have some of these smaller stars that are kind of conserving their energy. And I like thinking about it like that. Like if you're running a race, right? You don't want to just sprint, right? You want to keep your energy going. That's kind of how small stars are thinking. It's a smart way to think. Stars also will appear brighter if they're closer to us. That was kind of what I was talking about before. They orbit at their own speed, and if they're obviously closer to our eyes, it's going to appear brighter. Same thing, if I bring my finger closer to my eyes, it's going to appear larger than if it's far away. It's just kind of natural way that things are, okay? So I hope that kind of makes sense as to what a star is. Okay, so now we're going to talk about what is a planet, and then we're going to get into tackling those questions. But it's important that we have this kind of fundamental understanding of what actually these space things are. So the definition of a planet is something that's been kind of constantly evolving and changing. But the International Astronomical Union, which is just a group of like astronauts and space nerds that kind of get together, they created a set of qualifications that have to be considered to be a planet, and they established this in 2006. So it's kind of like some criteria, like a to-do list. So basically the criteria for a planet are: 1, it has to orbit a star. 2, it has to have enough gravity to force it into a sphere shape. And 3, it has to have a clear path of orbit, clear path. So even though you might be thinking, wait a minute, you said there's no gravity in space. How do planets have gravity? So even though there is no gravity in space, planets can have gravity, and that's what keeps them in orbit and attracts them to moons and other space particles. Okay, so planets do have gravity. It's just that in space doesn't have gravity itself, but planets do have gravity. So let's get that kind of straightened up, because think about Earth has gravity, we're a planet, but space in general doesn't have gravity. So there's 8 planets in the solar system, and the solar system is what we call the planets that orbit the sun. Okay, the sun is a star. So there are a group of planets that orbit the sun, and of course one of them is Earth. Earth is right here, you can see it. There's Earth, we have Mercury, Venus, Mars, Saturn, Jupiter, Neptune, and Uranus. Okay, so there's 8 planets in the solar system. These are the solar system planets that like to orbit the sun. That's the star that they orbit. And they orbit in a circular path, okay? They go around in like a large circle. So there's kind of, we group the planets, we kind of separate them. So Mercury, Venus, Earth, and Mars, these are like these 4 ones you see right here. Sorry, I keep saying that, the slide thing keeps on going. But Mercury, Venus, Earth, and Mars, they orbit closest to the sun. And they actually are more made of dust, okay? So they're made of dust, rock, and metal, but they orbit closest to the sun. Whereas Jupiter, Saturn, Uranus, and Neptune, the 4 outside, they orbit farthest from the sun, and those are made more of gases, okay? And the gases kind of swirl around, and they make these planets super duper cold. So we have the rock-based, kind of dust-based planets, and the gas-based planets. These planets, okay, you also may see that they have rings, and they have rings because their personal planet little gravity is able to rip apart any moons and comets that might come close to the planet. And when they get too close, those pieces break apart and they start actually orbiting the planet, which is super duper cool. So they have this kind of gravity feature where they can take in little rocks and get them to spin around them. So that's kind of how that works for those 4 gas-based planets. So just remember, even though there's no gravity in space, planets do have gravity. And even though I'm talking about planets right now that orbit the sun, there are lots of planets that orbit other types of stars you maybe never have heard of. And they're called exoplanets, okay? So exoplanets, again, they're orbiting, they meet all the qualifications, those 3 qualifications to be a planet, but they just choose to orbit a different star. So you can see here, there's tons and tons of exoplanets, and NASA is discovering plenty more, so it's really kind of exciting. Okay, so I got a question, and I'm like, this is a really good question. It said, what about Pluto? You know, isn't Pluto a planet? You know, why is it not considered a planet? And Pluto was discovered in 1930, so it was actually discovered quite a long time ago. And people suspected that was the 9th planet. So they kind of temporarily named it this Planet X. You know, what is Planet X? We see something, but we don't really know. And then officially in 1930, there was a student who was able to make it official and call it Pluto, okay? So Pluto, for a long time, we believed was a planet. We added it as our 9th planet to the solar system. However, Pluto ended up missing one criteria. And the criteria that Pluto missed was it does not have a clear path of orbit around the star. Okay, so Pluto does orbit the sun, but it doesn't have a clear path of orbit, which means that something's in its way that's kind of, it's sharing its orbit with it. Remember, orbit is just kind of its motion around the sun. So what actually is in its way is objects from Kuiper's belt. So Kuiper's belt, the simplest definition is it's part of the solar system. It's basically near Neptune. It has comets and asteroids in it. Okay, so comets are like ice dust balls Remember, there's dust in space, are kind of like icy dust balls, and asteroids, which are like space rocks. So Kuiper's belt is just filled with all this kind of like space junk, you could say, but basically has asteroids and comets, and it's near Neptune. But the problem is that in Kuiper's belt, guess who is also there? Pluto. And because they can't share, for Pluto to be considered a planet, it has to have a very clear path. And you see these other planets, they have like really clear paths. Nothing's getting in their little ring. But Pluto is out here. It's in Kuiper's belt, and it's interfering with some of those objects. So that is why Pluto was not considered a planet in 2006. They cut it down to a dwarf planet. So it's kind of a planet, but it's not really a full-blown planet. It's just called a dwarf planet because they don't want to be like mean. But it doesn't count as a planet because it doesn't meet all the criteria they established in 2006. So super interesting. And this is happening a lot. You know, they're checking these planets for criteria, and who knows what might be considered a new planet or what might be kicked off the planet. And this we'll have to see as time goes on. Okay, so another question was, why can't we live in space? And hopefully at this point you maybe have some ideas about why we can't live in space. But basically, we know that outer space, it has a little bit of hydrogen and helium, small amounts, but it doesn't have any oxygen, guys. And we need oxygen to survive. That's what we breathe in every single day. That's what I'm breathing in right now, and you guys too. So if we don't have oxygen, we can't live in space. And this picture is really kind of cool. If you look at Earth with oxygen and Earth without oxygen, you see that there are no bodies of water, that nothing is growing, no grass is growing, nothing, okay? So if we don't have oxygen, essentially we die. And you see our planet dying too. So that's why it's really important that Earth is so perfect for human life, because our atmosphere helps us kind of trap in that oxygen that we can use to breathe. Another reason that we can't live in space is that the temperature and pressure is really not right. It's super duper highly pressurized, and it's not the right temperature for us to live in. We need suitable temperature, and that's another reason why Earth is perfect. It has water, and it lets in the perfect amount of sunlight to keep us at a temperature that we can survive at, okay? And it helps us protect us too from sometimes the sun is so strong, but that atmosphere lets in just the right amount. It's kind of like an umbrella. Another reason too is that, well, actually, I'm gonna move on to this. So my next point then is that there are some planets that NASA has been investigating that are not in the solar system. So that means that they don't orbit the sun, but they actually might be suitable for human life, okay? They're always kind of looking at some of these planets and, you know, looking, okay, do they have water? You know, what do they provide? Will it be suitable for human life? So one of them, and these are exoplanets, one of them is Kepler 62f, and that's what I include a picture of right here on the right. I'm circling it. And another planet is Kepler 62e. These are exoplanets. And the reason why they've been considered suitable is because they have water, oxygen, and they also have a suitable temperature for life. So they're definitely being considered, and probably no time in our lifetimes will we be moving to a new planet, but it's definitely something that they're kind of looking at and studying. But for right now, exoplanets are kind of the main guys they're looking at to be suitable for life outside of Earth. Now, another thing, you may have heard about humans inhabiting Mars, okay? There's lots of talk about this. And in the solar system, if we were to inhabit a planet, you know, a lot of times people are like, Mars would probably be the next best planet we could take over. Which is, I guess, kind of true, but not really, because the gravity on Mars is a third of the gravity on Earth, okay? So think about that. We're standing on Earth right now. We're sitting on Earth. On Mars, we have a third of that gravity, so a third of that attraction that's kind of binding us together, which means, honestly, we're probably going to be floating around a little bit. So that's the problem with Mars, is that it's just not suitable because there isn't enough gravity to hold us down to the Earth, you know, hold us down to the planet. And obviously, if we're floating around, that's not good either. So our best bet, in my opinion, and I think the opinion of many scientists, you know, is for living in space is an exoplanet, hopping onto an exoplanet. But we wouldn't be orbiting the sun anymore. So that's kind of strange, but interesting. Okay. So here we go. Whoever drew that, there you go. Thank you. So now the next thing, are extraterrestrials real? And what would happen if we found them? Okay. So thank you for erasing that. So extraterrestrials, can you guys please not write on there? Can you please remove that? Thank you. So extraterrestrials, right? I'm sure you've heard about alien sightings, X-Files, UFOs, Area 51, all this crazy stuff about aliens. And the media and kind of what we listen to and hear has really tried to hype up alien life. But to be honest, there's no scientific evidence to support there are aliens, okay? There's sightings and all that kind of, you know, crazy stuff, but there really isn't any scientific evidence. Now, the only scientific evidence we do have is there was a scientist who decided, you know what, I'm gonna conduct a survey to see how would people feel if we did have aliens on Earth? You know, what would the response be? And oddly enough, people were really positive about it. And they said they'd be willing to invite aliens to the planet and be willing to live with them and coexist with them. So even if we did, not saying we do, we have no scientific evidence to back that there are aliens, but if we did have aliens, we would probably, as a planet, as a human race, we'd probably react pretty positively to the aliens, okay? So with that, I want to leave you guys with, I call it my dinner table discussion. I did this last time. If you want to be a good scientist, the most important step you can take is talking and communicating with other people, okay? Because everyone has different opinions and everyone knows different things, and you're always learning something new or sharing your ideas when you discuss with people. So tonight, with your family, I encourage you guys to discuss this question. What would Earth be like if we did not rotate around the sun? If we were around a different star, would life on Earth still be possible? Kind of think about what do we need for life on Earth, and would we still be able to get it if we didn't rotate around the sun? And maybe if we rotate around a different star or no star at all, how would that work? We would be not considered a planet anymore, but you can kind of think about some of the consequences that would have if something were to change, okay? So now I'm going to do a little experiment. This is my kind of quick experiment, and then I'm going to do a bigger experiment. But we're going to take a look at kind of what a star really looks like. I've been talking about this whole collapse idea, but now we're going to take a look at actually what I mean by that, okay? So I'm going to stop sharing my screen. I'm going to go back to me, and I'm going to go through this, and we'll kind of take a look at it, okay? So now, okay, there we go. I'm back up. So now I'm going to show you guys something. So maybe have you guys ever played with kinetic sand? Yeah, maybe a couple times before. So I have a little ball of kinetic sand right here. I'm gonna hold it up. Oh, let me see. There you go, it's a little bit easier to see. Is it kind of dark? Can you guys see me okay? It looks like it might be kind of dark. I'm gonna roll down my umbrella so you guys can actually see this. Sorry, I keep switching around here. Okay, there we go. That's a lot better. All right, so you see I have this little ball, and this is kinetic sand, okay? And we're gonna watch what happens. I was talking about this collapse of a star. So I'm gonna kind of poke it, and we're gonna see that really slowly, it's actually starting to open up and to fall, okay? You guys can see this really slowly. See how it's starting to collapse in my hand? Okay, super slow, but I see it moving. Maybe bring it a little bit closer, but you see that this ball just keeps on collapsing and oozing out, okay? It's slow, I'm gonna help it along just a little bit, but you see now? The sand is just kind of melting in my hand. All right, and maybe that chunk was a little bit too big. I'd maybe use a smaller chunk next time. But of course, stars, it's going a lot faster, but that whole idea of a collapse is still going on. We have this collapsing ball of dust, okay? So it's something to kind of think about for you guys. So now, this is a big experiment that's super duper cool, and I think you guys are really gonna enjoy it. Is we are going to model space and what sound is like in space, okay? So remember how I told you guys there's no air in space? Now, what we're gonna test is there any sound in space? If I were to talk, if I were in space right now, would you be able to hear me, okay? Maybe, maybe not, but we're gonna go ahead and test it out with a little experiment with a little bit of music, all right? So I'm going to unplug, I'm gonna turn around so I can show you guys what my experiment's gonna be, all right? So. Let's see here. Right. You guys can see me pretty good. All right, good. So today, what I'm going to be doing is I'm going to be playing around with using a vacuum sealer, a vacuum food sealer, okay? It kind of looks like this, and I'm going to show you guys. You can maybe see it there. But basically, usually you use vacuum food sealers for food. A lot of times it's used for meat to help preserve meat. But what we're going to test is it's going to try to mimic what space would be like. Remember how I said space is a vacuum? There's no air in space. Well, we're going to mimic it right here. We're going to see if we can hear something. So the first thing I'm going to do is I'm going to play for you guys a little bit of jazz music. And I want you to listen. This is a volume experiment. So it's all about listening to what the volume of the sound is, okay? Because that's when you're going to see a big difference. So please, guys, make sure that you're making no noise. I'll leave questions at the end, but listen to how loud this music is. Hopefully you guys can hear it, yeah? You hear it, right? You hear that music kind of going? So now what I'm gonna do is I'm gonna take my phone and I'm gonna put it in space. All right, you guys will see what's gonna happen. I'm gonna put it in the vacuum sealer and we're gonna try it out. So here we go. I have my vacuum sealer right here. I'm gonna put it in the bag. This is a vacuum seal bag, guys. It's just to help, oh man, this umbrella's kind of, basically the vacuum seal bag, sorry, I'm gonna pull up my umbrella a little bit to make it easier to see. All right. I have my music going, guys. You can still hear my music. Good. So I'm going to go ahead and put my music in the vacuum seal bag. Okay, you hear how loud it is, guys. Just I want you to hear that. Okay, so it's getting a little bit quieter, but not really. But now we're going to try vacuum sealing it up. All right, so here we go. Putting my bag in. This is just a little machine. I have put it in the vacuum. There's like a little vacuum channel for me to put it in. All right. I have to seal it up. Vacuum it. Here we go. All right, here we go, guys. Hear the machine working? So I'm gonna just let it run, guys. Give me 1 second. Vacuuming it up. Okay, guys. So my phone has officially been vacuumed. Do you guys hear anything? No, right? There's no sound. And why is there no sound? Because we're in space, technically. But basically what I did with my phone was I sucked out all the air. And sound can only travel if we have air particles. If we don't have any air particles, sound can't travel, okay? It's a big, big thing. So no air particles, sound cannot travel. So now if I'm to open this bag up, let me see here. It's gonna be hard to open. But if I were to open, see, okay, I'm gonna actually, here we go, I have a cutter here. Let's see. I'm gonna open my bag up now this time. Here we go. I open my bag up. You guys hear how loud it is again? Right, so you're hearing the music now. Okay, so I'm back to now the same volume I was at before. So if we want to talk about what's actually going on, guys, so what happened was when I vacuum sealed my phone, okay, I sucked out all the air, and sound cannot travel if there is no air. So when I sucked out the air, the sound couldn't travel. That's why you guys couldn't hear it. But now, when I opened up the bag, you can hear it back to normal volume. So you can hear that totally change in volume difference. And that's because I sucked out all the air, okay? So I hope that makes sense to you guys and why in space you guys can't hear any sound, okay? I want to leave time. Is there any questions that you guys have? Anyone want to ask a question about anything we talked about today? Any questions? Anybody? Any questions? Oh, here in the chat, looks like somebody asked something. Okay. Can you guys hear me okay? Yeah? Okay. So does anyone have, let me get my headset back on so I can hear you guys if you have any questions. But, let me hear any questions, guys. Anybody? If you have a question, you can unmute yourself too. You know what? I can't hear you. I'm sorry. Can you unmute yourself? SG, I think you're still on mute. Hold on, I still can't hear you. Let's see something. No, SG, I still can't hear you. Can you type in your question on Zoom group chat and I'll answer it? Huh. Okay, so he's asking why is space so cold? Okay, cool. Yeah, no, this is great. Okay, I got it. Perfect. So the reason that space is so cold is, remember how I'm talking about those air particles, right? How like they take in the sunlight and they kind of distribute it. That's why the sky is so blue. It's like they're able to like filter in that sunlight. Same thing with space. If you don't have any air in space, there's nothing for those. There's no like air to absorb the sunlight in to make it actually warmer. Okay, so I hope that makes sense. You know, in here, like on Earth, we have air particles are able to take in that sunlight and then release it as light and also as heat. But in space, we don't have that. Okay, so hopefully that kind of makes some sense. Does that make sense to you? Yeah. And okay, cool. Yeah. And everyone that said, can you send my mom an email, the recording? I am going to be posting the recording on YouTube. So you can go ahead and log in and it'll be sent out to everybody too. Okay. Anyone, any last questions before we log off? No? All right, guys. I hope you guys like the experiment today. I know sometimes those ones with sound are kind of hard because we're doing it virtually, but I hope that you heard. Oh, someone raised their hand. What is that? Let me see. Ava C. Ava, if you want to, do you want to ask your question? Just type it in because I don't know why it's that. Sometimes I can't hear them now. Let me see something. Huh. Okay. Ava, you're on mute. Okay, if you want to ask a question, you can unmute yourself. Okay, maybe not. Okay. Oh, it's an accident. Okay, cool. So, guys, thank you for coming today. We will be having our next meeting. I'll be picking something new to talk about and doing some new experiments. But I hope you like the vacuum seal experiment. I know sometimes technical difficulties, but I think it's kind of cool how now you guys know in space, we don't have, oh, it takes hours to drive to space. I think it takes more than an hour. And I think we need to make a new roadway if we want to get to space. We need an aircraft, you know, so definitely some kind of rocket ship to get to space. I don't think we could drive there. But I hope you guys like the vacuum seal experiment. If you guys have any questions about anything we did today, please send me an email or reach out to me and I would be happy to answer it. So I hope you guys enjoyed. All right. I'll see you guys next time. Bye. Bye-bye, guys.